Hi everyone, welcome to today's webinar. This webinar is a presentation of Clean Energy Group's Resilient Power Project, and it's presented with the Northeast Electrochemical Energy Storage Cluster, also known as NESC. Our topic for this webinar is Hydrogen and Fuel Cells for Resiliency, Secure, Sustainable, Resilient Energy for Commercial and Residential Buildings. And we have two excellent guest speakers with us today. Before I pass it over to them for their presentations, I'd like to go over a few quick housekeeping notes. All of our attendees for this webinar are in listen-only mode. You have two options to connect to the audio portion of this webinar. You can either call in using your telephone, or you can use your computer's mic and speakers to connect. A very important note, we ask that you please submit your questions as you think of them throughout the webinar. We will save some time at the end of our presentations to address questions from the audience. We'll try to save about 15 minutes for that. We do expect a lot of people to attend this webinar. We had a lot of people sign up, so we should get a lot of questions. To make sure that we get to your question, type your question when you think of it. Put it into the question box on your webinar console and hit send. We'll read through those and get to as many as we can at the end. And finally, this webinar is being recorded. You will find a recording of this webinar as well as all of our previous webinars in this series on our website at resilient-power.org. And with that, I would like to pass this over to our host for today's webinar, Todd Olinsky-Paul. Todd is a project director here at Clean Energy Group.
Great. Thanks very much, Samantha. Welcome everybody to the webinar. And this is another in our series of webinars on fuel cells and hydrogen for resiliency. We have a couple of excellent speakers here, and I'll introduce them in a minute. But before I do that, I would like to do just a brief introduction on Clean Energy Group and our Resilient Power Project. As you could see on the screen, we have a number of foundations that support the work that we do in the Resilient Power Project, which basically is looking at putting resilient distributed energy into critical infrastructure so that during power outages, such as might be caused by a storm or other natural disaster, the critical services can still be maintained, and that includes not only first responders and police and fire and health facilities and communications and fuel and transportation, but also places where people live in multifamily housing, and where people can better shelter in place rather than having to evacuate. So if you could go to the next slide, please. So we've, in addition to doing these webinars, we do a lot of other things. The Resilient Power Project publishes a number of reports every year, and along with blogs, we produce newsletters. We do all kinds of things. It's all free and available on our website, and you could see on the screen there's several images of reports we did recently on fuel cells and hydrogen. They're basically like little case studies. You can find those on our website as well. Next slide, please. I also want to mention that NESC, as Samantha said, the Northeast Electrochemical Energy Storage Cluster, sponsors and supports this work. NESC is a network of industry, academic, government, and non-governmental leaders working together to help businesses provide energy storage solutions, and you can visit them at nesc.org online. Next slide, please. So with that being said, I'll introduce today's speakers, and we will get on with the main presentations for today. We have Bruce Becker and Jesse Hayes, and I'm going to introduce them in the order that they're going to speak. So first up, we'll have Bruce Becker. He's a registered architect and lead accredited professional with more than 25 years of experience in planning, design, and real estate development, and he is the president and owner of Becker and Becker Associates, which is located in Fairfield, Connecticut and Manhattan. Becker and Becker has planned, designed, and developed over 3,000 units of housing and a wide variety of educational, commercial, and mixed-use projects with a value of over $500 million. He has earned a Master of Architecture and an MBA from Yale University, as well as a BA in American Studies and Fine Arts from Amherst College. After Bruce, we will hear from Jesse Hayes. He is product manager at Doosan Fuel Cell America. Prior to joining Doosan, he served as the National Solution Sales Engineer at Schneider Electric, where he focused on distributed generation and microgrids. He's also managed the electrical design and utility interconnection team for UTC Power's Installation Services Group, where he was responsible for over 40 megawatts of fuel cell utility interconnections. And he's held several research and development and project management positions at Proton Energy Systems, involving fuel cell systems, hydrogen generation and fueling, and power electronics. Jesse graduated from the University of Connecticut with a BSEE, magna cum laude, and he is a certified energy manager and member of IEEE Power and Energy Society and the Association of Energy Engineers. So, welcome to both our speakers. We will start, as I said, with Bruce Becker from Becker and Becker Associates. I just want to remind everyone who's on the line of two things before we start. One is somebody always asks, or usually multiple people ask, whether the slides will be available after the webinar. Yes, they will. In fact, the entire webinar is recorded and will be archived on our site, and you can review it at any time. The second thing is that I want to remind folks that we will be taking your questions after the presentations are over. Please go ahead and type those questions in on your webinar console as they occur to you. Don't wait until the webinar is over, or until the presentations are over, and then everybody tries to type in their questions all at once. We will get to as many of them as we can, and I would ask you to send them in as quickly, as early as they occur to you. Okay, thanks, and we will now start the first presentation, and I'll pass this over to Bruce Becker.
Great. Can you hear me, Todd? Am I clear?
Yep, you're loud and clear.
Very good. Okay, well, my name is Bruce Becker. I'm the president of Becker and Becker Associates, and I'm an architect who is also a developer. And over the last, well, since I was practicing as an architect back in starting in 1988, my practice has evolved to be sort of an integrated architect and developer, which has allowed me to think broadly and creatively about the energy systems for my buildings. And as a result, I've been able to dive pretty deeply into adopting renewable energy for my projects. So I'm going to talk today and over the next 20 minutes about 3 projects that my firm has designed and developed, one in New York City and 2 in Connecticut. They're significant in that they're, I believe, the first 3 multifamily projects in the United States of any scale that are powered and heated with fuel cells. So I think I'm going to try to advance the slide here. Very good. Oh. So just briefly, the firm has a 60-year history. We've developed about 3,000 apartments, including emphasis on affordable housing with mixed income projects and projects that are all affordable. And we pride ourselves in this integrated process and focusing on environmentally sustainable and economically strong development, and more focused on cities and trans-story development. Briefly, the first project we did this scale was the Octagon on Roosevelt Island. That's part of Manhattan across the East River from the Upper East Side. And it's a project where we had a pension fund partner, MEPT, and launched that in 2008, and then came back and put a fuel cell in after the building had been completed. trying to advance the slide here. A bit of delay, maybe. Oh, here we go. Yeah, so I'm going to just show you a couple pictures of it. There was a historic hospital that had been in ruins. In fact, it was only about 3 stories of what you see there in the foreground, and the wings had been demolished, the old hospital wings. So we recreated 2 wings on the footprint of where the hospital was. This was the one of the first mental asylums in the country, designed by Alexander Jackson Davis in 1840, and went through a reincarnation as the Metropolitan Hospital and then became a ruin. And so it was a adaptive reuse of a historic structure. It qualified for LEED Silver based on integrating a lot of different measures, including what at the time was the largest photovoltaic array in New York City with just a 50 kW array. Since that time, they're much larger ones. But we also integrated sub-metering, which allowed us to recover our investment from our tenants, and also provided the infrastructure so that when we added additional sources of generation, such as the fuel cell, it was a seamless process. So we had a 600 kW base load for the building, 24/7 demand for heat and hot water with domestic hot water. We put the fuel cell in 2010. It was about a 6-month process to retrofit it. We basically sat it out next to our tennis courts and provide power to the 500 apartments and run excess power back to the grid. It was about a $3 million investment, a little over $2 million for the fuel cell itself, the balance being installation costs. And we had incentives that covered over a third of that cost, including a NYSERDA grant, just an upfront cash grant. And then we also qualified for the 30% federal tax credit. It saves us over $220,000 a year annually. And without any of these incentives, it would be a 14-year payback. With the incentives, it's a 5-year payback, which is the equivalent of getting a 20% return on investment, this is a project which was sponsored by a pension fund that's, if they can get a 10% return, they're happy. So this actually increased their return on investment. And I think now it's saving close to $1 a square foot in operating costs. So it's quite successful economically as well as environmentally. A little difficulty advancing slides. I don't know if Samantha can assist me with that.
If you want, we could ask Samantha could advance them for you if you're having trouble.
Yeah, why don't you do that? Because there seems to be a delay. I'll just say next, if you don't mind. Next.
I think, Bruce, there's going to be a little bit of a delay either way, unfortunately.
Oh, okay. Well, maybe I just need to be patient. While we're waiting for the slide to advance. Oh, well, this slide talks about the emissions. I don't know if we can go back, but they're, well, we don't need the slide, but the amazing thing about fuel cells, I mean, I think they're, I consider them to be sort of the trifecta of clean energy, because it's a form of distributed energy, it's clean renewable energy, and it's a form of combined heat and power, which makes really efficient use of the energy in the natural gas, which gets converted to hydrogen. And it operates, unlike other forms of renewable energy, it operates 24/7. It's the most resilient form of renewable energy in that it's always going. I think our runtime is 99% between these three. So, but the environmentally, it has the great feature of reducing particulate pollution by 99.8%. So, particularly when you're located in cities, you have the advantage of eliminating, what's a real source of childhood asthma and sort of urban pollution by eliminating all of the NOx and SOx that are otherwise present even when you run a boiler. So trying to advance these. I can, if we want to just, if you can advance them, Todd, or
Sure, I'm happy to advance them for you. If you want to regain slide control at any point, just double-click on the webinar viewing screen there.
Oh, I see. Okay, there we go. Well, I was going through the program here in New Haven. We also developed a 500-unit project called 360 State Street, which is the largest apartment building in Connecticut. And it is it also has 500 parking spaces. It has a ground floor grocery store, other retail, and this was the redevelopment of a site over an acre in downtown New Haven next to the State Street train station. And trying to advance the slides. I don't know if there's an easy way for someone else to do that for me, but we can just sort of advance them very good. So you're seeing pictures of the community, the rooftop terrace, the gym, swimming pool, the typical apartments you see here with great views. Part of the purpose of this project was to bring people back into the city. If we hold this slide, there, we explored several different approaches to renewable energy. We drilled a test well for geothermal. We found there wasn't sufficient groundwater to support that. We would have had to have something like 35 wells. We also looked at rooftop solar. We could have fit a 100 kW array on the building, but that would only have provided enough power for about 3 to 5% of the load of the building. We looked at wind, which would have provided significantly less. And that's what really brought us back to the fuel cell, because that can produce virtually all of our heat and power and is completely resilient and quite economical. Next. So you can see some of the information on the fuel cell economics. We had a base load for the building of 475 kW. So we knew that we could use the power of the 400 kW Doosan fuel cell very efficiently. I should mention that the model that we use for all three projects is the same, although the first one was built by United Technologies, briefly owned the production and product line, and of course now Doosan has taken that over. Thankfully, they're very well capitalized and provide a lot of stability and comfort for our investors. There were similar incentives with a 30% tax credit. We had an LREC contract. Actually, for 360 State Street, we had it was one of the last cash grants from the Clean Energy Fund, but that was about $1 million. And I'm optimistic about the future for fuel cells in residential buildings. There are 16 million multifamily units in the United States. It's about 21% of U.S. energy usage, and there's very little renewable power in the multifamily market. Part of that is because of issues with submetering regulations, which are starting to get easier to use, but it would take 35,000 fuel cells, and then all the multifamily buildings in the country could be powered with renewable off-the-grid electricity. It's definitely possible. I was interested hearing the Democratic National Committee platform. There's now talk about having sort of a World War II level effort to combat climate change. I would think that fuel cells should be part of that because they do such a great job of creating resiliency, more efficient use of, while they do rely on fossil fuels, they're the only way to use fossil fuels without combustion that I'm aware of. And maybe they can be part of this recipe for our energy future. It could be a much bigger, significant role. I'm going to actually allow Jesse to talk more about how fuel cells work, but very simply there are three components. The first stage is the conversion of the natural gas to hydrogen, and then there's the second stage, which is the fuel cell itself, the electrochemical catalytic process, and then the conversion of DC power to AC power. And there's a long history of them going back to the 1800s. In Connecticut, we had issues with submetering regulations, whereas in New York State and at the Octagon, the regulations have actually encouraged the use of fuel cells and other renewable power, with submetering being actually approved as of right since 1988 in Connecticut. You could only use submetering as subject to discretionary approval of the DPUC and now PURA. There was the utilities were I guess had to be persuaded to support the use of fuel cells and submetering, which they came around to, thankfully. But it took us 6 years to get regulations that allowed for residential submetering, so that we can actually recover our investment from our tenants in our buildings. Really, the two regulatory issues that affect the ability to use renewable energy are submetering and net metering, both of which are helpful. At 360 State Street, we qualified for LEED Platinum, which is the highest level, by using a wide range of energy efficiency and environmental features. This is a photograph showing the fuel cell being installed. It's at 360 State Street. It's actually in an inside location right next to our backup generator on the ground floor off of an alley. It weighs 60,000 pounds. It was delivered. We had a celebration when the crane arrived and put it in place. It's about the size of a tractor trailer or a container. And I think this shows it in position. We do have a complete heating plant, but it doesn't really need to run most of the time because we get almost all the thermal energy we need from this very quiet, combustion-free fuel cell. That's me standing in front of it on the left. And that's the rest of our mechanical plant on the right, which is up on the second floor. But that's really just a redundant system which only has to kick in on the very coldest days or when we're doing service to the fuel cell, which is really just every once in a while. It's monitored. The fuel cell is monitored centrally by Doosan. So the case study for 360 State Street is a little bit different. We have we now have just converted to submetering. So now we're actually using 100% electric utilization, and we've always been able to use the waste heat. The fuel cells will have to be replaced in every 10 years. The economics are similar to the one in New York. Our investment was $3.5 million. About half, a little over half of that was the cost of the fuel cell itself, and we had similar incentives with the cash grant and fuel cell and also rec sales. We also get a discounted natural gas rate in Connecticut, so that makes the natural gas that fires it a little bit less expensive. And we save close to $300,000 a year. Similar payback of 5 years with the incentives, 13 years without. And it does a remarkable job of reducing our carbon footprint. This shows the relationship between different types of housing and the savings in carbon footprint relative to a detached single-family house. And you progressively, as you get more dense types of housing and greener types of housing, you can reduce what is sort of a typical carbon footprint for housing unit to something that is less than 20% of that with 360 State Street. I'm going to rush through because I think I'm approaching the end of my time frame. So these are just some pictures of 360 and trying to advance the slides. Okay, this is just some photos of 777 in Main Street. That's the typical plan. We took the Bank of America Tower and we gutted the floors and we put 13 floors in 13 apartments per floor. So now we have 285 apartments, and it's the largest apartment building in Hartford. This is what it looked like historically when it was built in 1967. And you'll see the boardroom and some of the original offices. We kept all the historic spaces. This is the bank lobby, parking garage with retail. And this is the facade of the building. bank lobby, the floors before we gutted them, which were office floors, the top penthouse. These are pictures from the outside, which actually there's a nice shadowing feature that comes from the precast modules. So the building was fairly green to begin with in terms of its construction. And with the quite a few different energy efficiency strategies, including the fuel cell and combined heat and power, it's designed to meet LEED Platinum status. You'll see some pictures here of the apartments, which have magnificent views looking back and forth north and south of Connecticut River. Very high ceilings, 9 feet throughout. We have things like Nest Learning thermostats. We installed interior storm wind panels to increase the thermal performance of the building envelope. We used formaldehyde-free cabinets and millwork. But this building is now about 90% leased. In fact, I'm giving the presentation from it. And we leased up in about half the time we expected because we found that there's a real interest with all different types of demographics for living in green buildings in walkable downtowns. Every apartment has a washer dryer, has Energy Star appliances, and the energy bill is a fraction of what it would typically be because we're using combined heat and power, and we're using all of these various techniques to reduce the building's energy use by 50% relative to code and benefit from the combined heat and power from the fuel cell. This is views from the wraparound terrace and the top floor, which is an amenity for all of our residents. And I think we have, this is the boardroom that was converted to a gym. And we have a yoga studio in the basement. These are some of the amazing views from the terrace. And I think we're going to see some pictures of the fuel cell. There it is being delivered to the site. It's just outside of our loading dock. Here it is in the foreground of our electric car charging stations. We have the largest collection of electric car charging stations, which are powered by the fuel cell. So we have not only clean, sustainable, renewable energy sources for living, but also for transportation. This is just a shot of our how we're able to meet the peak loads with the fuel cell for the building. We're actually putting a 100 kW solar array on the building. And thanks to these folks at the Pura who approved our sub-metering application, we're able to do that from the get-go. And here are the folks from UI who changed out our meters to sub-meters just a couple months ago at 360 State. So I think that is, oh, and then this is the coffee shop we have on the ground floor. I just thought it would be timely to show that because we recently had a visitor who was on national TV just earlier this week, standing up in front. We recognize him. So there we are. I'm probably taking a little more time than I should have, but I think I'm going to hand the baton to Jesse and look forward to any questions that come up about our work with fuel cells.
Okay, thanks very much, Bruce. Really interesting set of slides. Jesse, you ready to go?
Yes, sir. Thank you so much. Well, thanks to the Clean Energy Group for having us.
Okay, we're getting an echo from you. Are you on a cell phone by any chance?
I am not. I haven't changed anything on my end.
Seems to be okay now. Go ahead.
Okay, so thank you guys for having us. We'll talk about our fuel cell in respect to the sustainability and critical power. And thank you to Bruce Becker who preceded me to bring up 777 Main Street and the other two projects. Most notably, 777 Main Street is the first application of our fuel cell as the emergency power resource. So what that means is when the utility power goes away, our fuel cell is the source that provides power for the life safety loads initially. And 777 Main Street is a LEED Platinum, as was 360, and Octagon was LEED Silver, so doing very well in that respect. So we had to go through, with the engineer of record, the process of getting this fuel cell certified by the building inspector for emergency power. And that process was interesting, and we learned a bunch from it, and there's still a lot to be done. in the future, because a lot of the codes are written that mention fuel cells, but really it's not done a lot, but we think it's a paradigm shift. So next slide. We've been doing backup power and critical power for a long time, and here's a longtime customer of ours, First National Bank of Omaha, and they originally put fuel cells in 1999. And in addition to other things that they've done, such as getting redundant electric feeds and the pillar rotary UPS system, our fuel cell helps provide seamless transition in the event of an outage. So if they lose both electrical services, together with the rotary UPS and the fuel cells, they can basically not even see an interruption. And in 2014, we replaced some of the 200 kilowatt fuel cells with a 400 kilowatt fuel cell. And so that site is going on 17 years now with our fuel cells. So I want to talk briefly about how conventional backup power is done. The reason I want to cover this is because there's a lot of paradigm shifting ideas with using a fuel cell every day to save you money, and also using it as an emergency resource. So the diesel generator is the workhorse of the standby emergency power market, and when you really think about it, those systems are bought under capital procurement, and they are usually sized for the peak load plus quite a bit of margin, sometimes of the facility. So a lot of times they're oversized for the life safety and critical power loads, but that's a consequence of being a capital procurement and having margin. So we see these diesel generators sometimes fail to start and fail to run, as was the case in Hurricane Sandy when it hit New York City. A lot of generators fail to start and fail to run. They had to move people out of hospitals into different locations. They also require periodic testing, so there's a monthly testing basis for the generator itself. And when a generator starts up, there's a lot of exhaust that comes out that is raw without any filtration. There's also high greenhouse footprint when you consider a generator and using diesel to generate critical power. And you can always tell when the generator's on because it is quite noisy. And during long-term outages, there are logistical issues, for instance, with fuel storage and trucking. So Hurricane Sandy, when some of the facilities that we worked with, like a data center, were out for more than 3 or 4 days, they had to get fuel deliveries every 2 days. And finally, the diesel generators are electric only. They have no recovery for heat because they don't normally run. So to shift that paradigm, we take a look at the fuel cell as a resource that can be used to offset everyday energy from the utility, and also from heating fuel sources as well. So normally power comes from clean, reliable natural gas into our fuel cell, and we offset the usage that the facility has from the utility. And dedicated or emergency load panels are positioned behind an ATS, normally operating off the grid from their dedicated feeder. Now, our product now has a 10-second transition to critical power. As a matter of fact, we're looking at about 4 to 5 seconds transitioning from grid-dependent operation, so we're in parallel with the grid, to grid-independent operation. So we basically disconnect and then reconnect at up to our nameplate, 400 kilowatts, within 10 seconds. And some of the advantages are this asset is now used to continuously save money on everyday energy cost savings. It operates continuously, which basically gets around the monthly start up your generator and go through the testing mechanisms. So also when a fuel cell runs in backup power mode when the utility's gone away, it's hard to tell because it's quiet and there are no changes in emissions. It's still the same clean resource. Now, natural gas is our fuel, but this natural gas qualifies in many areas as a reliable source for emergency generation. There are some places where that's not acceptable, but where it is, this is a great solution. And there's also heat available during a grid outage. If there's an outage, our unit continues to produce electricity and heat, and our greenhouse gas footprint is still low. So to take a step back and look at the codes, when we were working with Ellen Consulting and the building inspector, we had several codes we had to abide by, and And basically I'm giving a quick overview here, so it's real quick, about the National Electric Code. Article 700 is where this fuel cell at 777 Main Street falls under. So it requires a less than 10-second transition. There are other types of standby systems that require different levels of time transfers. But we're proud to announce that 777 Main Street does have less than 10-second transition for critical life safety loads. A typical generator, as outlined in NFPA 110, which is the standard for emergency and standby power systems, is shown here. The systems are quite complex. You have exhaust intakes and battery systems and sometimes exhaust gas treatment and monitoring and so on and so forth. So the fuel cell is a little more straightforward. Our product is very packaged, very nicely packaged, and all we need essentially in addition to the fuel cell is a set of switchboard or switchgear that will transition from grid connected to grid independent operation. Now NFPA 110 calls out the types, the classes, and the levels of emergency power. And in the case of 777 Main Street, we're talking about a type 10, so which is less than 10 seconds to restore power to the critical life safety loads. And our class, basically, that has to do with how long the generator can run with its fuel, and seeing how as the natural gas is in Connecticut very reliable, our class is other. It runs indefinitely apart from the grid. And level 1, life safety. Level 2 is non-life safety, so we're falling under level 1 for 777 Main Street. Now, the fuel cell helps with the national initiative to accelerate investment in industrial energy efficiency. So there was a goal in 2012 to increase the amount of CHP in the U.S. by 40 gigawatts by the end of 2020. That was about half about as much DG or CHP as there was at the time. There was 82 gigawatts at the time. So they roughly wanted to improve the penetration by 50% in about 8 years. And the motivations for this, as Bruce Becker can attest to, is increasing competitive in the U.S. in manufacturing, lowering energy costs, freeing up capital for future investment, reducing air pollution, and creating jobs. And this slide basically illustrates the energy input to a system all the way to the load, whereas the traditional models from a central power generation plant along transmission and distribution lines and finally to the customer. With fuel cells, you can put this equipment to use on-site or to work on-site, where you can take advantage of the waste heat where it's not lost. And our electrical efficiency is about 43%, and we can also recover heat to get a total efficiency of about 90%. Now, natural gas is a very clean fossil fuel, as we mentioned earlier. And what sometimes I like to do is go to regions and show the amount of CO2 going into the local electrical grids, which I'll do shortly. But our fuel cell system is California Air Resource Board certified, that's CARB certified, and fuel cells can help eliminate criteria air contaminants and reduce greenhouse gas emissions by 60%, plus boast the critical power capability, and when all the heat is used, up to 90% total system efficiency. So it's important to illustrate the competitiveness of the fuel cell as a sustainable resource. In some states, there is a renewable resource or a low emissions resource. So I do that here, where we take a 400 kilowatt fuel cell and compare it to other initiatives like a 400 kilowatt solar system. If you look at the two systems side by side, you can see that a solar system produces about 500,000 kilowatt hours annually, where a fuel cell provides about 3.3 million kilowatt hours annually. That's 6 times the amount of energy that a PV does over the year. Really what that comes down to is capacity factor. The fuel cell makes more power all the time. And when you look at the effect on the central plant and trace back the greenhouse gases, our fuel cell offsets roughly 3 times more CO2 than the equivalently sized solar system. I like to tout the fuel cell as the lowest air emissions of any continuous duty power generation option. So there are other continuous duty power generation options out there, and we're the lowest. When folks might consider taking batteries and solar, that's not continuous duty, but it's very clean, so fuel cells need to be grouped in there with those other very clean technologies. So fuel cells can help reduce SOx emissions, NOx emissions, and CO2, as shown here. And down at the bottom left of the slide is the CARB certification limits and how we fall under those or we meet those. And if you look at the NOx emissions compared to other generation technologies, fuel cells are pretty much negligible. So how does this work? As Bruce mentioned earlier, we take in natural gas, we reform it to get hydrogen that goes into our stacks. Inside of our stacks, hydrogen and air cross paths across an electrochemical assembly, and that makes clean DC power, which is then inverted to grid quality AC power. We also make heat in that process, heat in the form of hot water, and we can make about 1.7 million BTUs per 440 kilowatt system. And the exhaust of the fuel cell is much like your breath. It's warm, moist, a little less oxygen, and a little more CO2. Some of the applications for heat are for hydronic heating systems and steam boiler preheats with our high-grade heat, which is up to 250 degrees Fahrenheit. Or we can do chilling as well. We can use a single-stage absorption chiller to make chill water for any sort of site. And then we also have a low-grade heat option, which is up to 140 degrees Fahrenheit for heating domestic hot water, condensing boilers, processed water, pool heating, and so on and so forth. Our fuel cell is very unique. Our phosphoric acid technology is a medium temperature fuel cell. It allows us to brag about our robustness and also our load following capability. These two slides here show real-world scenarios. One is a week worth of data on the left at a Coca-Cola bottling factory, where you can see the weekends where the fuel cell is load following with some minimum import level to the grid power, which is in blue. During the work week, the power at the facility rises and our fuel cell rises to its maximum level and continues to stay there for the rest of the week until the weekend again. The data set on the right is a 12-hour window showing how our fuel cell is mimicking the load profile of the facility. So that means our fuel cell can ramp up and down quickly without any other technologies to support it. And our fuel cell is flexibly sited. We can site our system outdoors, indoors, on rooftops, and we can also do multi-unit sites. So some of the photographs here, this Coca-Cola site on the left is actually the site where that Coca-Cola data set came from as well. 360 State Street is a fuel cell indoors that you see on the top right, and at the bottom is St. Francis Hospital in Hartford. Our fuel cell there replaced our Model 200 that was installed years before, and we're backing up the same emergency loads there. In that scenario, though, we're actually backing up the emergency generator. They have an existing diesel genset that, should that fail, there's an opportunity to do a manual lineup of our fuel cell as a last resort to power up those emergency loads. And advance the next slide real quick. Too fast. Okay, so you saw that at the Octagon building at 360 State Street and 777 Main Street, all of those had a LEED certification from silver all the way to platinum. And a typical brag sheet here for the environmental friendliness here is that we can offset CO2, or equivalent of planting 116 acres of trees, reducing NOx to basically take 87 cars off the road, and saving water, the equivalent of about 2.2 Olympic pool full a year. And we're about 65 dBA at 10 meters, no louder than piano music. Our fuel cells have been installed as backup power resources, usually optional, prior to 777 Main Street. So we have backed up facilities for a long time, and some of the more recent ones are the San Diego blackout in September, where we powered a grocery store, and the October 2011 winter storm, where we backed up South Windsor High School, a Whole Foods market, and the Connecticut Juvenile Training Facility. And we had 23 systems running during Superstorm Sandy. Some of those were not installed for backup power, but the ones that were ran through the storm. And finally, I'd like to tout our fuel cell's environmentally friendliness and its land usage in a graphic here. So in essence, our fuel cell can offset 3 times more CO2 than solar or wind, based primarily on our capacity factor. And we use a significantly less amount of land when installing. So you can see that a fuel cell makes 4,900 kilowatt hours for every square foot, which is order of magnitudes higher than solar and wind. All right, thank you very much.
Okay, thanks very much to both of you. I appreciate that there was a lot of information packed into a short time, and thank you for being careful to leave time for questions, which is the next order of business here. So we have a number of questions, a whole bunch of questions actually that people have sent in, and let's see if we can run through a few of these. So some of them seem to be directed to one or the other of you. So the first one is, how difficult were the interconnections with the public utilities? I'm thinking that's probably directed toward Bruce, and I think they're referring to the Octagon project, but you could maybe address it with regard to the others as well.
Sure. Every project had different challenges with interconnections. At the Octagon, which was a retrofit, it was relatively easy to do. We had an existing, we had 2 electrical rooms. Roosevelt Island is a little bit unique, but we had to work with Con Ed to tie in out of the transformer. It was a relatively seamless process, and certainly easier than running the thermal connections to the boilers, but did require regulatory approvals. At 360 State Street, that project was conceived at the outset with a fuel cell, so I would say it did not really add any greater difficulty to the process because it was just part of our plans and UI. When we got our plans to be served by UI, it was part of that mix. So that was really seamless. The challenge there was then converting the metering from apartments that were metered by the utilities to the submeters. And then at 777, it was more like the Octagon, where we came in from the beginning to with a tie-in. But the one thing we had to do in Hartford was we had to get off of the district service to a direct feed, and that required us to pick up some of the cost because we had to tie in from further away. We ended up relocating our electric room to a different location and drawing the power from a different street, and essentially abandoned the historic electric service. But it was something that we had a good teamwork between Eversource, our engineer, Dusan, and I would say while it required some good engineering, there were no real risks, and there was no great uncertainty. We just had to map it out and implement it.
Okay, great. Somebody else wants to know, again on the Octagon project, were the savings due to reduced energy charges or reduced demand charges or reduced capacity charges or something else?
It was primarily just the standard usage charges. Because it's it picked up over 80% of our electrical load. It was just a direct reduction in our use. That did have the effect of also reducing our peak demands, But as with 777, we have solar panels on the roofs, which is actually that's really what makes the contribution to shaving the demand charges, because with an apartment building, the peak loads are typically in the summer with air conditioning, and they correspond to the maximum output for the solar. So one of the reasons we went ahead with the 100 kW solar array at 777 was in part for the savings, because we were just exceeding the output of the fuel cell, so we were able to generate, sort of rebalance our production to meet our demand. But that helps us follow the demand profile a little bit more and shave it down to minimize our peak loads.
Great. And again, in relation to the cost savings, somebody wants to know whether there was any performance guarantee requirement on the project cash flows. In other words, did the pension fund or anybody else, require any performance guarantees?
Well, the wonderful thing about the fuel cell, as well as with solar, is it's really just an engineering. When you invest in any kind of real estate, there's a lot of uncertainty. Are you going to get the rents that you expect? Things like renewable energy are far less risky, because these fuel cells are proven. There are hundreds of them on operation. You can predict their operations, within 0.5% or even greater. We do extensive energy modeling, so we know how efficiently we're going to use, where our loads will be, and the pension fund we work with, the Multi-Employer Property Trust, is most of the investment managers are LEED certified, and they are committed to sort of responsible investment. And the only thing that we had to guarantee that we would secure the subsidies, both the 30% tax credit and more recently in Hartford, as part of our financing with our partners, we've had to give them assurance that we will secure the LREC award. And so we've been able to do that. As a developer, your partners always want you to be on the hook for performance, but we have enough confidence in Doosan and their fuel cell that we're willing to, I think we're able to get everyone to be confident in the performance of the technology. The issue that probably was a little more uncertain is whether we were going to secure the incentives. And I've been an advocate for removing that uncertainty. I actually prefer the good old days when you could go to the Clean Energy Fund and get $1 million cash grant. Now you have to bid in a sort of reverse auction market for LRECs. You don't quite know what the subsidy is going to be until 6 months after you've committed to having a fuel cell, essentially. And while I know back when the DEEP put this program together in Connecticut, they thought it would make the subsidy market more efficient, I'm not sure it's done that. I think sometimes these LREC prices have actually gone up over time. But in terms of what the investors look for in terms of guaranteeing performance, I'm sure that depends, on who it is. But in our experience, the bigger question is, are you going to get the subsidies that you expect, not is the fuel cell going to perform as expected?
Okay, great. Obviously, there's a number of benefits from the fuel cells, and you've mentioned several of them. One would be a resiliency benefit, and another would be benefit of lowering the costs of energy in various ways. Have you or has anyone that you know of done any kind of study to determine what, if anything, what are people willing to pay? What are residents of these buildings willing to pay as a premium, if anything, to to get those benefits? In other words, is there any kind of study that says, well, people are willing to pay an extra X amount per month for resiliency, or for knowing that they're using, you're using clean energy and you're going to get fuel, cost savings over time?
I think that that's an excellent question. I would say that we don't provide I don't believe that we're getting a premium. I don't know that anyone is paying extra. I do think that it is a factor that helps.
Yeah, I wasn't asking if anyone's paying extra. I think the question, and this isn't my question, that somebody has asked, I think it's whether anybody's done a study any kind of economic study to show whether people value it, and if so, at what level. So the kind of study where you'd say, well, what would you be willing to pay to get these benefits?
Yeah, Todd, I would say that study.
I think it's.
So yeah, I would say that study would depend on at what point in time you're talking about. If you were to do that survey shortly after the October snowstorm, it would probably everybody on that study would say yes, it's important. What that value is, I'm not really sure, but other than that, when power's the weather's nice and power's on, most people don't want to pay extra for those features.
Okay. Somebody wants to know, in the residential segment of the market, how do fuel cells compare to other energy storage systems? And I guess they are referring probably to batteries. Do you have any way to compare? Well, I don't know what basis you would compare on, but do you do that kind of comparison?
Well, I'll try and tackle this one. This could be a question about residential-sized fuel cells. And just to be clear,
I haven't actually used any energy.
Let's go one at a
fuel
time.
cell, which I'm not sure I consider to be energy storage.
Okay. Why don't we do this? Why don't we take Jesse and then Bruce?
All right. So one of our company's predecessors, ClearEdge Power, had a 5 kilowatt fuel cell for residential purposes. We didn't carry that product forward with Doosan, but we're looking more now at giving a larger group of residences, like the folks at 77 Main Street, Octagon, and 360 State Street, a fuel cell to use that on a community basis. That's probably the most attractive way for the consumer to take a fuel cell. There may be one day further down the road when fuel cells are everywhere or ubiquitous that we might offer a residential unit at some point in time. But for now, we see the immediate term where we can basically get a fuel cell to a group of residential folks together. And how it would compare to batteries and other storage technologies, basically batteries you need to charge up and then you need to discharge them. Our fuel cell just runs on fuel, on natural gas, and will go whenever you need it, making heat on the spot, which batteries don't normally take advantage of the heat on a battery, so fuel cells have that advantage. We're also continuous duty. We can also be dispatchable, which batteries can also be dispatchable. We can be dispatchable at any point in time. So there's a handful of technical differences between the two.
Okay. Well, this actually leads to another question, 2 questions that were sent in. Is there anything available for small solar off-grid applications in the fuel cell world? And then related to that, can a do-it-yourselfer buy fuel cells? And how does that? I mean, obviously we're looking here at larger systems that are professionally installed. But are those what's in the market right now for small and accessible fuel cells for off-grid applications?
Yeah, so I don't keep the pulse of that world all the time, but I do know that there are fuel cells out there that are smaller, and a lot of them might just be for pure backup purposes. They don't normally do anything like the diesel gensets, and then if there's an outage, they'll have a fuel cell kick on and provide power. There is a micro CHP movement where people are looking at fuel cells on the micro and residential scale. And those exist. I would say they're pretty hard to find, and there's probably a lot of barriers with it's it's not a ubiquitous technology out there, so it's going to be tough to find them or tough to procure them.
Okay, and I think this is going to have to be our last question. What do you recommend to people who are not connected to the natural gas grid?
Well, if folks live in the northeast region and are looking for a fuel cell and aren't connected to natural gas, they should take a look seriously, because a lot of natural gas distribution companies are looking to help folks put in technologies that will use a lot of natural gas and consistently, and they'll bring the lines to many locations to do that. So, for instance, we just had a ribbon cutting ceremony at one of our vendors who's got a manufacturing facility in Connecticut. Prior to the fuel cells, they did not have natural gas, and they procured 2 fuel cells which brought natural gas to their site for free, and they were also able to switch off their diesel and propane fuel sources. So they saved a lot of money by putting in fuel cells, bringing natural gas to their facility. So everyone should consider it. Whether you have natural gas or not, you may be able to get it at no additional charge or some reduced charge.
And municipalities have used fuel cells as part of their their sewer plants using methane.
Yep, correct.
So there are alternative fuels available.
Right, yes, there are alternative fuels, and any alternative fuels to the good pipeline natural gas that we talk about is probably a cleanup skid or some device before the fuel cell to get it to the right quality.
Okay, well, thanks to both of you. I apologize to folks who sent questions in that we didn't get to. We're out of time, and we got to as many as we were able. Samantha, do we have any upcoming webinars that you want to mention?
Well, we have several coming up. You can find more info on those on our website at resilient-power.org.
Okay, great. Well, thanks to Bruce and Jesse for spending the time and sharing your experience and expertise with us. And thanks to everybody who joined us. The webinar is recorded and will be posted on our website shortly. And we'll see you all next time.